This is lesson 11.6, Make and Interpret Line Plots. It is on pages 525 through 528 in your workbooks. So why is it never a good idea to have chickens play basketball? I mean, aside from the obvious reasons, why is it not a good idea for chickens to play basketball? There are just too many fouls. Chickens, fouls. But it would be kind of funny to watch them, wouldn't it? Moving along. So the learning target that we have for this lesson is to make line plots and use them to solve problems. And as always, I hope you can do it on your own by the end of the lesson. So let's do some looking back. Measure and record your height to the nearest quarter of a foot. Collect the heights of all the students in your class and create a line plot of the results. So for the sake of time, I'm going to take some random measurements of some kids and then write it down here for you to copy. Alright, so go ahead and copy those down and we'll go over the look ahead. Alright, so wants us to write two conclusions from the line plot. This is a couple of conclusions I can make. Most students are taller than 4 feet, and one student is 4 feet tall. So each of these X's represents a student. These measurements here represent the height in feet. Alright, and then the title is Heights of Students in Class. So the important thing when we look at a line plot is to see what each of these things mean and what the title is so that we can understand what is going on with the line plot and what kind of information it's giving us. Alright? So let's check it out. Our key concept, make and interpret line plots. Our example, the table shows the amount of water that 10 students each use for a science experiment. Make a line plot of the data. So they have our data here and then make a line plot. So one of them was 2/8, so that's why they have 2/8. One of them was 3/8. Two of them are 4/8. So the 4/8 we're going to make sure and put 2 of. Why did they put 4/8? Where's the 4/8, Mr. Pingburn? They're the 1/2. Yeah, see how they've made them all 8ths? And they've made all the fractions change to 8 as a common denominator. So how many students use more than 1/2 cup? So 1/2 is 4/8. Do they count the ones that are 1/2? No, they want the ones that are more. So they go 1, 2, 3, 4, 5, 6. So 6 students. So very important to make sure that you're paying attention to the question and the data it gives you. Well, all right, let's do some in-class practice. Number 1 says, the table shows the distances you swam each day for 10 days. Make a line plot of the data. All right, so the first thing we want to do is make all the denominators the same. Oh yeah, y'all thought we were done with fractions, didn't you? Let's make them all 8ths. 2 times 4, so 1 times 4. So all the 1/2 is going to be 4/8. And then the 3/4, change that to 8. 4 times 2, 3 times 2. So all the 3/4 are going to be 6/8. Alright, so let's put down here in order. Let me go ahead and put that for you. So we got 3/8, 4/8, 5/8, 6/8, 7/8. Alright, so now we need to go back through here and put X's on the spots that have the fractions. Okay, so each time we see one, so on 3/8, 3/8 here, we're just going to put 1 X. And then the 4/8, we're going to do the same. Now remember, 4/8 is 1/2. So we've got 1, 2, 3 of the 1/2 or the 4/8. So let's put 3 x's there. And I'm going to need to make my x's smaller if I'm going to put 4 x's on the 6/8. So let me make that smaller. Alright, so on 5/8 there's 1. On 6/8 there's 4. Let me get that 5/8. And on 6/8, well, Mr. Premier, there's no 6/8 on there. Yes, there is. That's 3/4. 1, 2, 3, 4 of them. And then the last one is 7/8. And there's one of those. Alright, so we've put all our data on there. Put it in order. Notice that I started with the smallest, ended with the largest. Right? I don't start at 1, 2, 3, 4, 5, right? That would be kind of silly. We need to base our numbers on the data that we have. Alright, so then what else do we do? Well, what does up here mean? What is this up here? Well, that's our title. What are we going to put there? Well, what do those X's represent? Yeah, the swimming distance. So let's put the swimming distances. And then what does down here represent? Yeah, the distance in miles. So let's put distance in miles. Alright, so we've got our title, we've got the distances, we've got our data. Let's answer the question, how many days did you swim 3/4 mile or more? So 3/4 is right here, and then more would be here. So 3/4 or more. So we got 4 here, 1 here. So that's 5 days. So we're going to make a line plot, and then we're going to interpret that line plot from the questions it gives us. Alright, let's go to number 2. So it says the line plot shows the number of students in each class in a school. How many classes are in the school? So let's look at it. So we get the class size here, students here, right? And so all of these represent the number of students in each of those classes. So in these 3 classes, in each of them there's 21 students. And it wants to know how many classes are in the school. Does it want to know how many students are in the school? No, it wants to know how many classes. So each of these represents a class. So count those up real quick. Count those up. Right? Yeah, see it says I can interpret a line plot. This is what it means by interpreting a line plot. We're answering questions from the data the line plot gives us. So count those up to see how many classes there are, and then we'll go over it. Alright, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 classes. 17 classes. Right? So we're looking at the line plot, looking at what it means, and then answering the questions. Alrighty, well, let's do number 3 here. It says the table shows the amount of mulch a landscaper orders on 10 different days. Make a line plot of the data. I want you to go ahead and do that. Make a line plot of that data, and then we'll go over it. Alright, so first thing we need to do is figure out our amounts here, right? And again, let's do eighths. So our first one, do we have any 1/8? No. Do we have any 2/8? There's a 2/8. How do you know, Mr. Penguin? Well, 1/4. We're going to make it 8, right? 4 times 2, 1 times 2. We get 2/8. So 2/8 is our first one. What's our largest one? 7/8, right? Because we already did 1/2 is 4/8. 3/4 is 6/8. All right. So let's start putting it there. And well, actually, let's put our labels and stuff down here. And then I'm going to put how many times each of these happen. So I'm going to go ahead and mark the X's. Alright, so I've got 1 of the 1/4 of the 2/8. I don't have any 3/8. I've got 2 of the 4/8, which is the 1/2. I don't have any 5/8. I have 3 of the 6/8, which is 3/4, and then I have 4 of the 7/8. All right, and then what I'm going to title it is mulch amounts for landscaping. Now you could have titled it something a little different, just like mulch amounts or something that has to do with that, right? It can't be like lollipops, right? That would be kind of silly. All right, and then on the bottom, I'm going to put amount of mulch in tons. All right, oh, let me move that. Okay, so the only thing it really needs to exactly look like are the X's. The X's need to be in those spots, okay? So, as long as it looks something like that, you're good. Number 4 says, on how many days did the landscaper order more than half a ton of mulch? Well, 4/8 is half. So all these would be more than half. So that would be 7 days. All right, so using our brains, right? Still dealing with fractions, because you can't escape fractions, can you? Looking at the data, making our chart there, and then interpreting. Alrighty. Let's go ahead and stop there for today, and then tomorrow we'll start on number 5. This is lesson 11.6, Make and Interpret Line Plots, still found on pages 525 through 528 in your workbooks. Today we'll start on page 527. Anybody know what nosy peppers do? And I bet some of you even know the answer to this question. What do nosy peppers do? They get jalapeno business. Oh my word. Moving along. Number 5 wants you to divide a package of seeds into bags weighing ½ an ounce each, and then you divide another package into 1/4 ounce bags and a third package into 1/8 ounce bags, and it wants you to make a line plot of the data. Well, you have not divided whole numbers by fractions, have you? We haven't done that. Right, this one wants you to divide 2 ounces into 1/4. This wants you to divide 2 ounces into 1/8. Okay, I'm going to give you the data on that, and then you can fill out the data. Okay, so here's what we're going to do. And here's what that data is going to look like. So I said 2 divided by 1/2, right? Now, we're going to do this later on in the year, but I want to show you now. When you divide a fraction, you keep, you change, and then you flip. And now we can just do the top and the bottom, so that's going to be 4. So 2 divided by 1/2 is going to be 4. 2 divided by 1/4 is going to be 8. And 2 divided by 1/8 is going to be 16. So you have 4, 8, and 16. So 4 of the 1/2, 8 of the 1/4, 16 of the 1/8. Okay? And so what we can do, you've got our data, 1/2, 1/4, and 1/8. You got how many of each? Okay? So I want you to go ahead, fill out this line plot, and then we will go over it. Alright, so here's what it should look like. This should be the 16 X's on the 1/8, 8 X's on the 1/4, and 4 X's on the 1/2. I titled it bag weights, and then the measurement's going to be, or the label down there is going to be weight of bags in ounces. And you know, these to look the same. You know, if you put 1/8, 2/8, and then 4/8, that's fine. I just put the actual fractions there. We can go over that and see what you put to make sure that you are accurate in what you described. Alright, so find the total number of bags of seeds. The total number we can either count those up, count all those x's up, right? Count all these x's up. We can just add these right here too. So we get 16, 8, and 4. So 16 plus 8 is 24. 24 plus 4 is 28. So there were 28 bags total. Now, most of the time, especially on tests, you're not going to be asked to actually make a table, but want to make sure you know how to do that, right? To be able to make these line plots, right? I want you to be able to do that, but more importantly, I want you to be able to interpret it, to be able to answer questions about it. All right, number 7 is going to be a you be the teacher. Your friend says the line plot is incomplete. Do you agree? Why or why not? Well, let's look at this line plot. What's missing? Yeah, there's a couple of things missing here, right? So I'm going to say I agree, and why or why not? This is what I'm going to say. There's no title or labels, right? There's not a title here. There's not labels here. I mean, we know that there's some stuff. We don't know what it is. We don't know what the measurement is. Don't know what those X's mean. Don't know what those numbers mean. All right, so yeah, I would say it's incomplete as well, because we wouldn't be able to answer many questions from this line plot. All right, let's connect this to real life. In our example, you recorded the amount of time you surfed each day for 8 days. Your friend surfed the same total of time, but for an equal number of hours each day. How long did your friend surf each day? So think you add the total number of hours you surfed. So we're going to add all this and get 24 over 6. So you surfed a total of 6 hours, right? So your friend surfed 6/8 or 3/4 hour each day, right? Because he's going to take 6 divided by 8. All right, that's how we got that. So I can use a line plot to solve a real life problem. That's what we're doing here. All right, number 8 is a little complicated, so I want to do that together with you. We'll go through this. All right, so you recorded the amount of time you skateboarded each day for 12 days. Your friend skateboarded the same total amount of time, but for an equal number of hours each day. So how long did your friend skateboard each day? So you skateboarded this much time in 12 days. So different times, right? Like 4 different amounts of times you skateboarded over those 12 days. Well, your friend skateboarded the same amount of time, but for an equal amount of time each day. So here's what we're going to do. Let's add all those up, right? Go ahead and do that. Add all those up. Now look, don't just add up 0.5 and then 1 and 1.5 and then 2 and 2.5. This is a 0.5. This is a 1, this is a 1, this is a 1, this is a 1, so that would be 4, okay? So go ahead and add those up and then we'll go over it. Alright, so we've got a 0.5. I've got 1, 2, 3, 4. 1.5 and 1.5 is 3. 1.5 and 1.5 is 3. So I'm adding 6. And then 2, 4, 6. And then 0.5, 0.5, and 0.5 is 1.5. 1.5, not 1.7. 1.5, so that's going to be 7.5. 7.5 and 7.5 is going to be 8. So 8 plus 4 plus 6, that's going to be 18. 18 hours. Right? So I'm going to divide 18 by 12. Right? 18 divided by 12. 18 hours, 12 days. I'm going to have 1 and 6/12, or 1 and 1/2. 1 and 1/2. You see how I got that? I added up all my time. It was 18 hours. Right? You skateboarded 18 hours in 12 days. Well, I'm going to take the 18 hours and divide it by the 12 days. I get 1 and 6/12. Right? Because I take 12 away from that, I have 6 left, and then I simplify that. 1 and 1/2 hours each day is what your friend skateboarded. We can do this, peeps. We can absolutely do this. You just have to think about what's going on. All right. So number 9 and 10 have to do with this line plot, the number of cars sold. So I think this is a Jolly Rancher moment for you. I want you to go ahead and answer 9 and 10. 9 and 10. If you get both of them right, at least one Jolly Rancher for you. All right, go ahead and do that, and then we'll go over it. All right, so how many total cars were sold on the 2 busiest days? Well, we got Wednesday and Friday, right? Because these two were the ones that they sold the most of. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cars sold on the 2 busiest days. The 3 least busiest days. Well, which ones did they sell the least? We've got 2 on Thursday, 3 on Tuesday, 3 on Sunday. So 3, 6, 8 cars. All right, so hopefully you looked at that, thought about the questions, looked at what it gave you. That's what it's all about. Well, let's go back to our learning target. Make line plots and use them to solve problems. Hopefully you can do that. You can make a line plot. You can interpret a line plot. In other words, answer questions about it. And you can use a line plot to solve a real life problem. Hopefully you can do all those things. And of course, I'll love you. If you're still at a number 2 and you need some help with it, I'll be glad to help you. Just ask. And then you peeps who know how to do it and can even show someone can help your peeps who are at a number 2 still. Well, all right, y'all have a good day.